Okay, so now that we've completed the building blocks of polynomial, or building blocks for polynomials, we can move on to actually determining and working with these things called polynomials now that we know the power function. And essentially the way to think about a polynomial is just a collection of power function terms added together. What do I mean by that? Well, every term has to have a coefficient, a variable, and then a power, and that power has to be 0 or higher and an integer. So, it could be 1, 0, 1, 2, 3, 4. So every term has to have this form, and then you can add as many together as you'd like. And that's how you decide whether you actually have a polynomial. So let's take a look at this first one here in 8. Well, we can take a look at each term here and let's evaluate them. Well, does 4x squared look like that form? Well, yeah, it has a coefficient of 4, has a variable of x, and it has a power that is 0 or greater and an integer. What about this guy? Yep, 5 is a coefficient, x is a variable. Here, you have to just remember that when there's no power written, there's an implied 1, so that's okay. Just because it's not written as a 1 doesn't make it not a polynomial. And the same thing here. Constant terms are always considered a polynomial because you can always write this as -1. Well, that's the coefficient, so -1 x to the 0. So we can see that, we don't see it here, but we could write that as x, put an x to the 0 in there, and so that also satisfies our definition. So just remember that whenever you have an x only, there's an implied 1, and numbers, constant numbers are includable as a term in a polynomial. So this one is, yes, all three of those terms satisfy the criteria, add them together. This one, not a polynomial because x here is in the exponent. That's an exponential function. In order for this to be a polynomial, it has to be a specified number that's 0 or higher and an integer. So that one fails. This term would be okay, but this is the term that kills this one. Here, well, if you remember negative exponents, if we wrote this with exponents, this would be 6x to the -2 plus 5x to the -1 plus 4. That term's okay, but these terms have negative exponents, and so therefore that does not meet the criteria. So this one is not a polynomial for that reason. Okay, so I'm not going to go through all of these. I'll just maybe point out why the ones that, just a couple tricky ones here. So this one, these other ones are all polynomials, and I'll let you reason through why. This one is not because that has got the coefficient, it's got the variable, but that exponent is not an integer and positive, or not negative. It's a 1/2, so that's not a polynomial. And then these other two are polynomials. Don't let the fact that the coefficients can be decimals, roots, irrational numbers. That's fine. The only thing is we got the variables here, and those are okay. And then the same thing here. This is, you can rewrite that as x to the 1, 6x to the 0, also a polynomial. Type by degree. Remember, well, degree is essentially the highest exponent. Find the term with the highest exponent, and that exponent is the degree. So here, this will have a degree of 2. Also, well, this one's actually not a polynomial, so that doesn't matter. Here we search through the terms, we see a 10, so that's a 10th degree polynomial. Tricky maybe here because you have to remember this as 8 times x to the 0 because that equals 1, so this will be a 0th degree polynomial, which we also just would call a constant. This is a 5th degree polynomial, not a polynomial. This is a degree 20, and then x minus 6, you have, as long as you remember there's a 0 and 1 power here, this would be a 1st degree polynomial, which is also just called linear. And I guess this one we could say is also called quadratic. So that's how you find the degree, is find the term with the highest exponent, and that is the exponent is the degree. Number of terms, this is just counting them up, so like maybe the thing to remember here is that if you have the special names, if there's 1, 2, or 3 terms, it's monomial. Binomial if there's 2 terms, and it's called a trinomial if there's 3 terms, and if there's more than 3, you just call it 4 terms. So I'm not even going to go through this. You can I just wanted to point out that that's how you classify them. If you look on the answer key, you'll see why. Or you can just check why I have the answers I do. Leading coefficient, this means find the term that gave you the degree. So it's the coefficient of the term that provided the degree. And it's called leading because we're going to talk about in a second about standard form of a polynomial. If you rewrite polynomials in standard form, you put the highest degree term first, and so the coefficient becomes the first coefficient you read. So the way we're going to find this then is we're going to find the squared term gave us the leading coefficient, or the degree. So the leading coefficient is 4. This one's not a polynomial, not a polynomial. Here, well, this is the term that told us a degree of 10, so the coefficient of that guy is 5. This is 0 degrees, so that's just 8. Here, -1 is the coefficient. Don't forget that negative sign is an implied 1. Sorry. And then, not a polynomial. Here, degree of 20. It's -0.1. Make sure, even though you're subtracting this term, that negative sign has to be associated with that coefficient. And then this last one would just be a leading coefficient of 1 because there's an implied 1 in front of that term which told us the degree. Okay, for this question 9 here, I'm just going to provide the rationale. So end behavior, if you remember, it's what happens as x gets bigger in these directions, and so end behavior can either go up to infinity on this side, it can go down to infinity on this side, or down to infinity. So that's really what we're trying to ask ourselves, is if we graph this polynomial, what does it look like if we just look at what happens to the ends? And the key idea here is you can, even though polynomials have lots of terms, if you just look at the term that provides the degree. So that highest power term tells you everything you need to know about the leading coefficient. So if we look at this, everything you need to know about the end behavior. So if we look at the first expression here, 4x squared is the term that told us the degree. So all we have to do for this one is think about what happens to the end behavior for 4x squared. Well, we just spent the first part of this unit talking about that. We see that this is an even number, so we know that it has to go in this direction, and it's not reflected because the leading coefficient is a positive number. If this was a negative number, these would go down instead. So that's why the first one, I'll erase this here, we don't need the negative number, is just the end behavior is going up in both sides like that. Now let's maybe go through the second one, and then the rest you can kind of do on your own from the answer key. This one here is the term that provides the degree. So now we just have to decide and ask ourselves what happens to 5x to the 10th. Well, we know x to the 10th is an even, so it's got arms that go up. And then when we stretch it by 5, those arms still go up. We're not turning them and flipping them down. So this one also will have end behavior that looks like this. Let me just find one that has a negative leading coefficient. Let's do this one here. So this one, that's the term that told us the leading coefficient, or that told us the degree. And so here, we just have to understand what happens with the term x to the -5th. Well, we know x to the 5th has the disco function end behavior, but since we're multiplying it by a negative, this reflects down to here, and this reflects up, because that's what reflections do. So we'll erase those, and this would be the end behavior of negative x to the fifth. So hopefully that gives you enough to go on to reason through the others, and you can check the answer key. And then lastly, for number 10 here, you're just rewriting polynomials in standard form. This just means put the terms in decreasing order of powers. So now don't look at the leading coefficients, look at the exponents themselves and put them in decreasing order. So if we remember this as 6x to the 0 and 2x to the 1 and x to the cubed, we can see that this is the highest, this is the next highest, this is the next highest. So this would, to put this in standard form, you would put the x cubed first, 2x plus 6, because this has an exponent of 3, this has an exponent of 1, this has an exponent of 0. So this would be the polynomial in standard form. And the same thing would apply here. You just got to put them in decreasing order. Well, 11 is the highest, so that's why that goes first. 10 power is next. 7th power is next largest. Minus 3x squared is next largest. And then x is the final one. So this is just that polynomial written in standard form.